Yeah, that's fine. So today topic is about Docker. So you might have heard a lot about Docker and you might have heard something about containers and everything. So we'll see what is this Docker, what is this containers, how it helps us solve these things. So before going to Docker, let's talk something about virtual machines, VMs. So what is a VM? I mean, why we are discussing virtual machine if it is a topic about Docker? Why, I mean, why we are talking about VMs, right? If you are the topic is about Docker, we'll see that. But yeah, let's first start with the virtual machine. Virtual machine is nothing but like, it's an simply it's a new operating systems within the existing operating system. See, this is my laptop, right? This is maybe let's say Linux or Mac something. Now I want Windows in this laptop. What I have to do? Of course, there are two ways. One way is I can able to like what is it? I can able to uninstall this back, whatever the OS it is there, uninstall it, and then reinstall whatever I want. Maybe let's say Windows. Correct? That's one of the approach. Or there is one more way. There is a concept called virtual machine where we can install this setup, this tool, whatever the virtual machine tool we are using, and we can able to within this laptop within the OS itself we can have one more OS that's called virtual machines. So there is something called hypervisor software. This is the one which will helps us in creating the virtual machines. So usually what happens is directly if you install OS here, it will throw error. Hey, there is already OS. Why you are installing again? But this virtual machine, what happens is this is the software. I mean, we just need to install the software. That's it. This is software where we install the software which will allow us creating multiple operating systems within the single system. Got it? So you might have heard about virtual machine, VMware. It is an organization where they develop tools. So VMware is one of the company where it developed the hyperware software for us. We can able to use these. They have cloud also, but yeah, it's fine. VMware is one of the tool. Oracle also, Oracle Virtual Box something. There is a tool called Oracle. Yeah, Oracle Virtual Box and ESXi. This is also another thing. So there are what I'm trying to say is about virtual machine, how it works, how we create it like that. Sorry. So this will be like how we use multiple operating systems in one machine. All we'll be doing is installing this software, virtual, I mean, hypervisor software. This hypervisor software is available in multiple tools actually. We can install any of the tools and we can able to use that. Like as I showed you, ESXi is one of the tool as well as we have this, what is it? VMware Player, VMware Workstation, Oracle VirtualBox. There are multiple tools like this where we install it and that's it. The software is available here. And then within the tool we can able to install multiple operating system. Got it? Mm, Let me show VMware. Yeah, this image, let's see this image. Not a good clarity. Yeah, this is the image. Let's open it in a new tab. Awesome. So if you see, this is a sample VMware workstation tool, how it looks like. And left side, if you see, Windows 10, Windows 7, Ubuntu 18, Ubuntu desktop, something is there. So four operating systems are there, right? And that too, this is, let's say this is a Windows machine because workstation is available in Windows. So within the Windows laptop, they have installed this tool called VMware Workstation, and they have installed four more operating systems inside that laptop. See, using this VMware Workstation, using the software called Hypervisor. See, of course, you can create 100 also. All depends on your laptop resources, your system resources. Like, see, here, if you see in this example, he created four. You can create 40. But will your system handle it? That's the thing. Maybe this system, whatever now we are seeing in the picture, maybe it can handle four systems, maybe. But your system only have 8 GB. It cannot handle, right? So depends on your. There is no limitation. All limitation is depends on your system configuration. If your system has 100 GB memory and 30 CPU or 40 CPU, you can have these four. But your system only have 16 GB memory and 2 CPU or 4 CPU. It cannot handle four, right? Maybe it can handle two or one something. Got it? So like that, we can create multiple virtual machines within a single host. Host means the same system, whatever we are using. We can able to use that. It all depends on your memory. Got it? So it's like within the operating system, we are having one more system. See, and how it looks like. Let's see. It's simple how it looks like. This is how it looks like. See this one. Hardware with hypervisor, we are installing. See, it's installing three operating systems, which is possible. Many people use these things. Many organizations, not people, sorry, many organizations. And what happens is, any other example? Maybe this one. So forget about this part containers. We'll see it later in this. But see the virtual machines. We have infrastructure, our laptop, or don't call it a system. You can call it system or a host. Both are fine. And see the hypervisor software. See here. On top of hypervisor software, we will see something called guest OS, which is nothing but our new operating system or new VM. You can see three. It means they have installed three virtual machines with whatever inside it, whatever applications inside it, which is fine. So like this. So what happens is with the help of this hypervisor software, we are installing the operating system. But why we call it guest OS? They are guests only because this is our original, right? My laptop is my original OS. Inside the OS, with the help of hypervisor software, I'm installing another OS. That is guest only. Until we use it, it will be there. After that, I'll delete it. So it's like you are installing a new operating system. Let's say you're installing Windows. There will be so many steps, or if you install Linux, there will be so many steps, right? It's like you are installing new operating system. Whatever comes with the new OS, whenever you install, everything will be present in the guest OS. It's like a new system only, except it is within your system using the software called hypervisor. It's not there won't be separate things for that. Just within your system only, you are installing another OS. That's it. That's why we call it guest OS. Got it? So you install three guest OS. As I told you, it can there is no limited number. You can go unlimited. All depends on your system resources. All depends on your system resources. Maybe this system, whatever here in this example, it can handle three VMs. That's why they have created three VMs. Maybe some other machine may handle 10 or something. They can do that. So all depends on your, as I told you, system resource. So all good here. Until so far, this is all good. Then why the hell we are discussing? We are, we're discussing about it. I mean, why the hell we are talking about container something called? And if you can see here in this image itself, they are comparing, right? This is a comparison, virtual machines and containers. But why all these coming in the first place? Why this came in the first place is which VMs are good. I mean, it's not bad or something. VMs are good, but there are few drawbacks. Few drawbacks. So one thing, first drawback obviously is the size. See what I told you. We are installing a new operating system again on top of our operating system. I mean our OS, our host, our system. We have the software, obviously hypervisor. On top of it, we are installing another operating system, right? So the burden will be there, obviously. The size you are installing new, as I told you, it's just installing a new OS. So everything, whatever required for that operating system to run, it'll come. I mean, it'll install. I meant to say. Got it? What I'm saying? So so you are installing a full operating system. It means the size will be more, obviously. Imagine, see, just check if you want to install Windows OS. Let's say you have to download ISO file, Windows 11 ISO. Just for sample, I'll show you. So if you need to install OS, you need any these kind of things, image, where you have to download an image and you have to install it. I just want to show you the size. I mean, I'm not installing it. Obviously, English. Yes. Let it load. What the hell? Let it load. Meanwhile, let's open. Oh yeah, it opened. So just click on download. Let's see. It asks for me to download. So the size, let's try it. See the size, 5.7 GB. This is just an image. So we have to download this and we have to install this in the virtual machine, in the hypervisor. It will be it will be like around 30-40 GB size for Windows. For Linux also same thing. For Ubuntu also, for Ubuntu, it's similar. I think 5 GB or something. I don't remember, but let's see, 5.9 GB. See, the image itself is 5.9 GB, and when you install it, there will be lots of packages will be installed unnecessary, even though we don't use any of those. So it will be coming around to 30 GB something. See the size is huge, right? That became one problem. Of course, not every system have limitations, right? Every system have resource limitation. No one just creates system with 1,000 GB memory or something like that. It's not a good approach. That's why they'll have multiple things, multiple machines instead of just one machine. Why? Because if it is goes down, gone. That's why they'll have small resources with multiple machines. So the size is more. That is one thing. That is one drawback. Another thing is performance. See, have you ever opened you might have using Windows, right, every day. Imagine you have to click on the button, how much time it will load. It'll take too much time. Same thing, let's say for Linux also. If Linux have UI, of course it will be faster, but still not fast as expected. Because they are operating system, they'll work like that only. It cannot run in 1 second. It cannot, it's not possible. It will take some time. So performance is little bit slow, of course. So it'll little bit slow. We can able to use that. Still, we can able to use it, but little slow. So two main things as of now. One is drawbacks in VM size is more and performance is little slow. What does that mean? Performance is the startup time, the boot time, and everything. And one more thing is, let's say my laptop is a VM. I have installed Jenkins 1.2 version as an example. Jenkins 1.2 version I have installed. Now I want to install Jenkins 1.3. It's not possible. Of course, it's possible with a different port number I can able to run. Jenkins port number 8080. I can run Jenkins 1.4, maybe new version in 8081. I can run like that, but I don't want like that. I want to access with 8080 port number maybe. Uh, or or imagine, let's say Jenkins 1.1 version or works on Java 17. Jenkins 1.2, whatever, 1.4, whatever I'm trying to use, it works on Java 21 or something. Correct. So there are require dependency changes are there, different requirements are there. All multiple versions can be installed in the same I mean same operating system, but with little complications. Little because system wide, if I install a package, it will be system wide. So you have to use that system wide package, right? If something goes wrong, we are gonna break the application. This is one of the things. So three things I told. One is size, another is speed, I mean, performance and everything. Because we are loading an operating system, obviously it will be like that. And next thing will be the applications, handling multiple versions with different requirements, different OS requirements. It can handle, but not that much. And finally, one more thing. Usually, what happens is with VMs, they can take a backup of the VM and they'll be shipping it. They'll be shipping it. What does that mean shipping? I don't. What does that mean shipping is? Simple. You know what happens? For 1 minute. Sorry. Yeah. So what does that mean ship? I did not get it. What does that mean is, so let's say I have some application or something. I have some code or something where it's running in the VM with some configuration, whatever it is. So what I thought is, so it will take some time to replicate, I mean, install the new OS and install all the dependencies, whatever required for the application. I will simply sh take a snapshot of this VM, snapshot like a backup, snapshot of this VM, whatever let's say this one, snapshot of this VM, and then I will share it to other, my colleague maybe who require this, so they can run this from snapshot they can able to create a new VM and they can able to use that. So this is called shipping. So we'll be using these shipping, you know, generally they generally will use this shipping approach. I mean, just take a snapshot from your VM, send that snapshot to anyone. They can download the snapshot and they can install a new OS. I mean, new OS means new VM out of it, and they can able to use it. So that when you take a snapshot and when you send them, all the required information, whatever present inside the tools, the configuration, what else? Everything, whatever present in that OS will be sent to them, right? Obviously, because you're shipping it. That's all. That's how shipping usually we do. But there is one problem here. See, I told you the size 30 GB, 20 GB, 40 GB, it will be a one VM. Imagine how much time it will take to ship this. See, first I have to take a template. Template itself, creating a template itself will take some time because of the size. So once you create a template, you have to share that template to your colleague. Again, it will take too much time because of the size, obviously. Got it? So the too much time in shipping the VM. So these four main problems we got. Got it? These four problems we got it. So now these whatever the drawbacks as I told does not stop using VM. So everyone still uses VM. Every organization still uses virtual machines. But after a few years, there is some concept called containers came and containers, not Docker. Remember again, containers. Containers came. What happens is these containers removed all these issues, whatever we are seeing. Right? These containers, we have discussed, right, what are the drawbacks of VMs. So these containers came without these drawbacks by removing these drawbacks, and people started using these containers. So same thing, it will provide same thing as virtual machine. Little different. We'll discuss that. And the containers overcame all the drawbacks whatever VM has, and people started working on it and using it since then. Since 2013, I believe, almost, yeah, 12 years. So yeah, that's fine. So now, starting from how container works now. What is container? How container works? If you see the difference here clearly, VMs have software called hypervisor. On that, we'll install multiple guest operating systems. It means VMs. Containers have container engine. It's again a software. There will be software which will install. So similar to hypervisor, there is a software called container engine. On top of our operating system, we'll install it, obviously, just like how we install other tools. And if you observe in the after container engine, I mean in the right side, there is no guest OS. See, there is no guest OS. It means no need to install any operating system, which means the size became very, very, very less, right? Size became very less. See here what happens in the VMs. We are installing an operating system. On top of it, we are this is application deployments. Let's say application we deploy Tomcat application. Let's say as an example, version 1, version 2, version 3, something. So if you see here, the guest OS itself does not exist. Why? Because containers does not have operating system or kernel. I mean, what's inside operating system? It's kernel only to run the operating system. So containers does not have this kernel. You know why? Containers uses the host kernel itself, whatever the operating system we are using. Let's say I'm on this Mac laptop, and if I install containers tool and I start using containers, those containers will use my operating system kernel itself, my operating system OS itself. Kernel, whatever is there, it will use that kernel. Got it? There is no separate OS for containers. Got it? That's how containers work. Simple. I mean, just to make it simple, that's it. So now with this, there is no OS. It means there is no kernel. There is no unnecessary package and everything. Right? The size became very, very, very less. And that one more advantage with the containers is they'll give exactly what you want. See how what happens is like in this one VM, we have to install an operating system, right? Of course, if there will be lots of things coming, even though we don't use it, we don't use them because those are system packages. But containers, what happens is it will just give you what exactly you want. Let's say you want, I mean, you have an idea like you want to install Jenkins. Usually in VM, what you'll do, you will create a new operating system, I mean new VM. You'll install the OS, or within that OS, you will install the Jenkins, correct? That's what generally we do. But with the containers, same approach with containers, how it will be is like we just create a container with Jenkins. So what happens now is no, because why directly I'll create a container. No, no OS here, just a container with Jenkins. So now this container will give you only Jenkins. There won't be anything else. And what's required for Jenkins? Maybe Java. So Java within, that's it. So no system packages, no OS, nothing. See how much, imagine the size, how much it will be reduced. I'll tell you a basic example. Ubuntu I showed you, right? 5.9 GB something, the OS it is showing. We have to install that, it will take around 30 GB, minimum. But same thing in a container concept. Ubuntu is around 64 MB or something. Ubuntu is 60. It's not an OS, it's a container. We are deploying a container. I mean, we're running a container. Within that, Ubuntu flavor is there. Without OS, Ubuntu flavor is there. But with how the hell it works then in the container? As I told you, the kernel it will be using the system. System is my laptop wherever I'm running it. Got it? So the size became very very less because container gives you exactly what you want, not other things. And container treats exactly everything as same. There is no difference. Here in VMs usually depends on the operating system. It will be different. There will be difference, right? But in containers concept, there is nothing like that. It will treat everything as same. Why? Because I tell you a sample thing. See, I think you might have seen this one, right? Ship containers. It's a box, like rectangle box, right? See, these are all rectangle boxes. You might see it. See, no matter what, they are all same. Observe here, they all will be same size. See, everything will be same size. See, it does not matter what's inside it. It's same. Outside, it's same. Maybe this one container, inside one container there may be people, they're kidnapping someone. In other container maybe they have some airplane parts, that airplane parts. Maybe in other container they have some cell phones and some all these laptops and hardware tech. In some other container there is something else, but it does not matter. When you look at the containers, they're all same, right? We does not it did not care about what's inside it. Based on what's inside it, the container shape did not change, right? Correct? So observe here, the container shape did not change based on what's present inside. It is same. We can store anything inside as long it fits inside it. Got it? So what happens is our containers, our here in the software technology, our containers also works like that. You can run anything inside. It will treat everything as same. There is no limitation, there is no special treatment or something like that. Got it? That's one of the advantage. So size became very less because there is no OS at all. There is no operating system. Because why? Because there is no kernel at all. It simply using the host kernel itself. Got it? That's what it is doing. So that's why containers became famous. Of course, one more thing is the size is less obviously. Correct? Just as I told you, MBs only, not too much size. So creating and deleting them is very easy. Creating the containers and deleting the containers very easy. Starting them containers is easy, and shipping them also easy. See, creating and deleting it will take some time here because we are installing the whole operating system, which will take some time. Deleting also will take some time. Similarly, as I told you, loading also performance also, right? Because you're loading an operating system, obviously the performance will be like that. So we cannot complain about it. But in here, sorry, in containers, there is no concept called kernel installing or something. So the size will be obviously less, and obviously it will be faster to create, it will be faster to delete, and as well as like it will be faster to ship. It's just MBs now. Simply you can just ship the container and send it to someone whoever is required. So it won't take much time. Correct, obviously, right? That's how containers works. Then what the hell Docker? Docker is a tool which developed to manage these containers. There are like Docker, there are multiple tools available in the market, but of course Docker is the most famous one. So we'll be using Docker to manage the containers. Correct? That's where the Docker comes. It's a software. I told you, right? Container engine. This is Docker provides this container engine. All we have to do is install the Docker container engine, I mean the software, and use Docker commands to manage the containers. Directly we cannot manage, right? We need some tool obviously to talk to them, to talk to containers and everything. So that's why the containers, that's why we use Docker for the containers. I meant to say, sorry. Correct? So that's about small introduction. I know it will be lots of confusion what the hell we are talking about so far. But once you start, working on it, it will be dead easy. You'll just easily figure it out everything because that's how it is, Docker. I mean, the first, yeah, as I told you every time, understand the concept. Don't just remember the commands or something. Understand the concept, and you will remember everything. Everything will be easy. Got it? So I shared the documents already now. Same thing, whatever I discussed, why we use containers, what is this virtualization, hypervisor and all, I mean these VMs, why we started using Docker, all those things I mentioned already in, uh, what is it, in the documentation which I shared. Got it? So today, maybe one small thing, we'll install Docker. Just one command, that's it. Mm, of course, you might have seen the logo here, Docker Desktop. In Windows, there is in Windows or Mac, you can install this tool, Docker Desktop. Even if your laptop, if you want to install, you want to practice, you can directly install Docker Desktop, which is fine. Or if you want to install in Linux operating system, yum install Docker, apt install Docker. I mean, let me log in. Sorry, I did not logged in. Linux. So it will take few minutes to start the Linux server. Just one command. That's it. Yum install Docker or apt install Docker. That's it. But I will see that. Don't worry. If you want to install your in your laptop, let's say Windows laptop or Mac laptop, simply this Docker desktop. So it will go to official website. Docker desktop is a tool, same thing. I mean Docker only we are installing, but the package name is different. In the Windows and Mac, you'll see the UI like this, but in Linux there is no UI, right? It's a command line only, so that's why you cannot see it. Install Docker desktop for Windows, Linux also there, but of course don't install for Linux and Mac also. I already have it, so no need of adding it. Got it? This will take some time as I mentioned. Very simple. Let me log into the machine. Yeah, I am inside the machine. Simple apt update -y. It'll take some time, don't worry. Now let's clear it. Apt install docker -y. That's it. If it is you, oh, Docker has no candidate. Why the hell? Okay, docker.io. Let's give it. See, it's installing. If you are in, let's say Red Hat or CentOS machines, use yum install. That's it. It's installing. See, it's installed. Let's see. Docker -hyphen version 27. When I started, it was Docker. What is the version? 1.11. That's the version, if I remember clearly. 1.11 to 27. Within 12 years, see how much it's changed. It's fine. Now we want to start this Docker service. S- As I told you, based on this image, we have installed the Docker tool, I mean the package, which will have this container engine. Of course, we have to start the engine, right? That's what engine is for. Systemctl status. First, let's see the status. See, it's running already. Let's enable it. Sorry. It's enabled. Done. Now Docker, there will be commands, of course. Let's not discuss it today. Let's not have too much burden on it. So it's fine. This is about introduction to Docker and Kubernetes. Sorry, what I'm saying. This is introduction to Docker, sorry, and the containers. You might have understand a little what the hell is VMs, what it's used for, and why the hell these containers came into the picture. So all we do is, let's say, I'll explain it maybe a little simple. I got a requirement that hey, inst install Jenkins. As I told you, install GitHub Jenkins because we need to check out the code and we need to deploy it through Jenkins. It means Jenkins Git I need because I need to check out the code. Deploy where? Maybe Apache or Nginx server, something. So what you do generally, you will create an operating system as per the VM. You create an new VM OS, or even see here also. Since 1 month we are discussing, right? What are these? These are VMs only, which I'm using. Virtual machines. Of course, maintained by cloud, not by me, obviously. But these are virtual machines. These are VMs only, which I'm using. Virtual machines. In the machine, I log in and I'll do whatever I want. See, correct? So I'll have a virtual machine, install all the tools, and then I'll work on it. But of course, Jenkins, I need maybe Nginx and what is that? GitHub. How much time it will take? Just I think the size also not much, right? These tools maybe within 1 GB only we can able to close these all these tools. But if you're installing in OS, within the VM data will come, even though we don't use it, but we need it, obviously, right? Even though we don't need it, I mean, we don't use it, we need it. That's all. Due to that, the size will become more. Instead of all that, same thing. I want container. Simple. I just pull the Jenkins container. I'll just download Jenkins container. We'll see it. I'll just download it. Just download it and I'll run it Jenkins. Maybe I think I'm sure it'll be 500 MB or 200 MB something. Because what I told you, right? You ask for Jenkins, it'll give you Jenkins only, not anything else. It'll just give you Jenkins. No Git, no nothing, no top Nginx Tomcat something. You ask for only Jenkins, it'll give you Jenkins. If you ask for GitHub, it'll give only Git. If you ask for Tomcat, it'll give only Tomcat to you. No extra things. Just if whatever you ask, it'll give you. No, not less, not more. The due to the size will be very different, huge difference. Of course, there will be few components inside this. Similar to this, we'll compare and we'll use it. Don't worry, we can able to figure it out. Like I'm saying, containers. How to create containers using Docker and where the hell they'll run. Of course, on your machine only. Obviously, it'll use your operating system. So all these things we'll discuss tomorrow. For now, or today, introduction is enough. Got it? That's all about for today. We'll discuss tomorrow. We'll continue tomorrow. All right. So any doubts so far, in this concepts? Anything? Any doubts? Anything? So yeah, if no doubts, we can close the call. Let's meet tomorrow same time. Sorry for the late today. It took some time. Yeah, it's fine then. Yeah, let's meet tomorrow same time. Bye. Bye all.